Hey, everybody. We are in lesson 9-7. This is of the Tennessee Revealed Geometry, and this is the law of sines. Okay, so how do you know it's a law of sines issue, or what kind of triangle am I looking at? First off, these are not right triangles. It's either an acute triangle where all three angles are less than 90, or it's an obtuse triangle where one of the angles is bigger than 90. So we have been looking at sine, cosine, tangent of right triangles. This is your Oscar had a heap of apples, or whatever you're using to remember this. But again, this is what happens when there is not a right angle. All right, there is a formula. Now listen, you don't use all of these at the same time. You only use two. So you've either got A's and B's, or you've got B's and C's, or you have A's and C's. But you don't use all three because these are cross multiply problems. The angles go on top. Remember, those are your capital letters, and the lowercase letter, those are your sides. These are your opposite to each other sides that go on the bottom. So if you're looking at angle A, if you have angle A, you would put it in for capital A, and its opposite side A would go at the bottom. If you had angle B, then that was what would replace the big B, and if you had its opposite side, it would go in the bottom. Then you cross multiply and solve. All right, so let's look at example number 1. So you guys, I'm in your workbook. I'm on page 549. Example number 1. It says to find the value of x to the nearest tenth. That's one number after the decimal. Okay, so how do I approach this? First off, this is not a right triangle. Therefore, it's not trying to figure out if it's a sine, cosine, or tangent. It's going to be one of the laws, and there are two laws, the law of sines and the law of cosines. So how do you tell the difference between the two, or which one to use? Okay, depends on what you've got. If you've got a matching set, it is the law of sines. If you do not have a matching set, it is the law of cosines. So what do I mean by matching set? I mean, do I have big A and little a? Do I have big B and little b? Do I have big C and little c? Do I have angle and its opposite side? And I do in this problem. What I have is angle A is 58 degrees, and the side opposite to it that runs between B and C, that's little a, is 9. So I have a matching set right here, which means this is the law of sines. Now I'm looking to find x, which is the side little c, because it sits in between A and B, and I have angle C. So I'm using the matching set A, and I'm using angle C to find little c. So in this particular one, I'm not going to use B. I'm going to use A and C, because those are the angles inside that I have information for. All right, so here's my formula. I'm going to replace angle A with a 58 and side A as a 9 right there. I'm going to replace angle C with 35, and its opposite side is x. So sine of 35 over x. I'm going to cross multiply x times the sine of 58 and 9 times the sine of 35. Well, you cannot multiply x times the sine of 58. And besides, you're trying to find x, right? So you got to do the opposite of multiplying, and that is to divide by the sine of 58. So we're going to have 9 sine 35 divided by the sine of 58. And you're going to grab a calculator. All right. So grab your calculator. Probably going to want to have a fraction over a fraction just to make your life easier. Because if you don't put this in a graphing calculator exactly right, it's going to give you the wrong answer. First off, make sure your calculator is in degrees, and your teacher should have taught you how to do this. All right. Get a box over a box, however your calculator works. On the top, you're going to put 9 sine 35. 35 goes in the parentheses because that's your theta. And in the bottom, you're going to put sine 58. And 58 is what goes in the parentheses because that's your theta. Hit enter. And remember, they want this to the nearest tenth. Y'all, that is one number after the decimal. And what I'm looking at is 6.087. Well, the 8 makes the 0 round to a 1. Anything 5 or higher makes it round up. All right, so there is example number 1. The answer is approximately 6.1. All right, let's go to our check. We need to find the value of D. All right, well, first off, I notice this is not a right triangle. Okay, so is it a law of sines or is it a law of cosines? Well, I've got to have a matching set. And I have angle C, and I have the side across from it. This is a law of sines because I have a matching set of C's, and I'm going to use angle D to find little d. All right. So I'm hoping, because I know my students are visual, but I don't believe this is going to allow me to do a fraction. So hopefully just kind of stay with me here. All right. So it's sine of C over side C. So it's going to be sine 37 divided by the side 98.4. It's going to be on the left side of the equal sign. That's my matching set. I have both C's. All right, now I'm going to use sine of angle D, which is sine of 59 divided by little d. I don't know what that is. All right, I'm going to cross multiply. B will be multiplied times the sine of 37, and 98.4 will be multiplied by the sine of 59. I know it's kind of hard to see when I've written it like this, and not necessarily as a fraction, but written out. Unfortunately, I'm just going to have to go with it because there's nothing else I can do. All right, the opposite of multiplying by the sine of 37 is to divide by the sine of 37. So D is now going to be equal to 98.4 sine of 59 divided by the sine of 37. All right, grab a calculator. You want a fraction, so we can tell our calculator exactly what's being multiplied up top and then exactly what you're dividing by. All right, so up top, put 98.4 times the sine of 59. 59 is what goes in the parentheses because that's your theta, that's your angle, divided by the sine of 37. And you're looking at 139 point. All right, round to the nearest, what can I round to? Round to the nearest tenth. So the 2 that's after the 7 just makes it a 7, stay a 7. So 137.7. So that side right there, D, 137.7. All righty, there we go. There's our check. All right, let's go to example number 2. So I'm going to turn the page. I'm going to go to page 550, example number 2. All right, using the law of sines, going to find the value of x. Okay, first off, not a right triangle. None of these angles are 90. That means it's either going to be a law of sines or a law of cosines. All right, so I see I have, I do not have a matching set. Now it says to find the value of x, which is little d, because it's sitting in between f and g, and that's opposite to angle d, which is 60. So these are the two things that are going to go together, sine of 60 over x. But I don't have angle g. I have little g, but I don't have angle g. So this is what I tell my students is a trick question. 3 angles of a triangle add up to be 180 degrees. So I need to get my matching set by finding angle g. And since 60, 55, and angle g add up to be 180, I'm going to take 180. I'm going to subtract these two to find what the missing angle g is. So 180 minus 60 and 55 is 65 degrees. That's my missing angle g, which will give me a matching set. Angle g is 65 degrees and little g is 73. That's across from it. All right, so here is what I have. I have a matching set of g's, 65 degrees over the side 73. And I'm going to use angle d, which is sine of 60 over its opposite side, x. All right, I'm going to cross multiply. All right, 73 will be multiplied times the sine of 60. X will be multiplied times the sine of 65. And the opposite of multiplying is to divide by the sine of 65. So grab you a calculator, put in 73 sine 60. 60 is what goes in your parentheses, that's your theta. Divide by the sine of 65. And I am looking at the side little d, which is x, is running from F to G, is approximately 69 point. I have a 7.5, and then 5 makes a 7, round to an 8. I have 69.8. All right, there is x. All right, we got a check, and it's a multiple choice. All right, here we go. I need to realize it's not a right triangle, so it's either the law of sines or the law of cosines, and I have a matching set. I have 141 degrees, opens up to be opposite side x. Ooh, all right, this is one of those trick questions again. I have angle 18, but its opposite side is unknown. I have a 13 side, but its opposite angle is unknown. So the first thing I got to do is do 180 minus 141 and minus 18 to find the missing angle, which is 21 degrees. So this is going to be sine 21 over its opposite side, 13, is equal to sine 141 over its opposite side, x. All right, for my visual people, I will write this down, and it's not going to be written down very nicely because it's not going to let me do a fraction, but sine 21 over its opposite side, 13, equals sine 141 divided by its opposite side, x. I'm going to cross multiply. X will be times the sine of 21, and 13 will be multiplied by the sine of 141. Well, listen, you guys, the opposite of multiplying is to divide. So I'm going to divide by the sine of 21 over to this side. 13 sine 141 divided by sine 21. And I'm going to grab a calculator and put all this in. So 13 sine 141, and on the bottom, sine 21. And when you hit enter, the side is approximately 22.82. The 2 makes the 8 round to a 9. So it'd be about 22.9. 22. Oh, they didn't round it correctly. Bad people, bad people. The answer is D. All right. So there is my check for example number 2 on page 550 of your workbook. And looks like I'm going on down to example number 3, which is a word problem. All right. So I see it is not a right triangle. And I have a matching set. I have 106 degrees, opens up to side 146.9, and I have a 24 degree, opens up to the side x. So this is a law of sines. And since this is all about law of sines, every problem I would assume is going to be a law of sines. All right, so here we go. 106 angle opens up to 146.9. So I got one sine of 106 over 146.9. Angle 24 opens up to x, so it'll be sine of 24 over x. Cross multiply, x times the sine of 106, 146.9, times the sine of 24, and the opposite of multiplying is to divide by the sine of 106. Looks like your answer is going to be 62.2. All right. So next up, the ambiguous case. Now, I actually did look at this, and the only reason I did is because one of my teacher friends that also teaches geometry, he's been teaching a long time, and as well as I have. And he asked me, "Look, have you ever seen this before?" And I was like, "No, I have not." After looking at it, we've always said there is no such thing as the bad word, the angle side. You know, or the side angle backwards. So I got to looking at this and trying to figure out what it was telling me. And it was looking to see if this was even a triangle or not. And so I got into it, and I mean, I realized that why would we even need to know if it's a right triangle or not? On the ACT, they're not going to give us a no solution on the law of sines. They're just going to give us a problem where you got to use the law of sines. So, knowing that, I have never taught this at all. I've never seen it before. I've never taught it before. So I had to go through and figure out what it was even saying. And basically it's saying is if you have an obtuse angle, that the third side cannot be less than one of the sides, because the triangle would not close. So there'd be no solution. It's either got to be bigger or not. So even if it's a right triangle, the hypotenuse is the biggest side. So it has to be bigger than the other two. And if it's an obtuse angle, then your side has to be bigger than the other two. Otherwise, it's not going to even be a triangle. So with that being said, let's just get into example number 4. All right. So it is not a right triangle. I am looking at a law of sines because I have a matching set. I have angle N and I have a little n. There's my matching set. So I've either got to find, the third side, but I can't use Pythagorean theorem because it's not a right triangle, or I got to find one of the angles M or P. In this case, it's probably going to be P because I have the side P, and not angle P. Okay, so here we go. My matching set is 32 with side 7. So I got sine 32 over 7. And I have to find angle P with its side 4. So it's going to be sine of P over 4. So sine P over 4, cross multiply. Now, because I'm doing an angle, or I'm finding an angle, we learned when we were using our sine, cosine, and tangent that I'd have to do the inverse. That's that little -1, sine of the -1. But I'm still going to cross multiply. So I'll multiply 4 times the sine of 32 and 7 times the sine of P. And the opposite of multiplying by 7 is to divide by 7. So they kind of skip that step. But what I get here, I've got to do the inverse sine of, because I'm still looking to get P by itself. The opposite of a sine is an inverse sine. So you're going to do inverse sine of all of this information right here. And that allows me to get the angle, the 17.6 degrees. Well, it's kind of hard to explain without actually doing. So keep in mind, hoping we're going to have a problem. We're actually got to work it out. All right, so now that I've got angle P, I can find angle M by doing 3 angles of a triangle equal 180. So I have a feeling that's what's coming up next. 180, yes, minus 32 and minus the 17.6 degrees. And that gets me 130.373. That's going to be angle M. Okay, so I got to find little m. All right, so here we go. Now that I've got angle M, I'm going to put sine of M over little m. And that's going to be sine of 130.373 over little m. And I'm going to use the sine of 32 over 7 again, because that was my original matching set, angle N and little n. I'm going to cross multiply and then do, because I'm looking for M, I'm going to divide to the other side. So, all right, 7 times the sine of 130, M times the sine of 32, and the opposite of multiplying is to divide by the sine of 32, and grab your calculator. Box over box, 7 sine 130 over sine 32, and I get approximately 10 point, round to the 10th would be 1. So the measure by angle P, shooting back up here, was 17.6 degrees. The measure of angle M was approximately 130.4 degrees, and little m is approximately 10.1. All right. So there's example number 4 from page 551. All right, turn to the next page. Example number 5. I'm on page 552 of your workbook. Okay, let's see what we got. Oh, this is the ambiguous case. Yeah, okay. So first off, that 10 is less than the 12. All right, since the measure of angle R is obtuse and 10 is less than 12, there is, well, it's not a triangle. No solution. No solution. There's no triangle, so it's no solution. And like I said earlier, ACT is not going to do that to you guys. They're going to give you a problem you can solve. At least I've always seen it as a problem you can solve. So I'm not even going to worry about example number 6. I would assume that you probably can't solve it. Okay, oh, I'm sorry, there is one solution. All right, so I'll leave that up to you guys to solve. All right, so we're done. We are done. All right, next up is your practice from page 553. All right, you guys have any questions, let me know. As you can see on your next page of your workbook, all of these problems are solvable problems. So yeah, ambiguous case. I've been teaching geometry for over 20 years, and I've never seen the ambiguous case. So why am I going to worry about it now? All right, you guys have a great day. Ask your teacher questions. Ask me. I'll help you. All right, guys, have a good one.